Okay, in this video, I'm going to finish section 3.1 because there was a lot of pages left in this PowerPoint, so I just kind of wanted to finish going over it in case anybody needed explanation of the final topics in this section. So we were talking about functions in 3.1, and now I'm just going to quickly go over how to use function notation, how to read it. And then we're going to talk about domain and stuff of functions. Okay, so if f is a function, then for each number in x in the domain, the corresponding number y in the range is designated by the symbol f of x. So I'm sure we've already am aware of this. We read this as f of x, and f of x is the same thing as y. So when a function is expressed in this way, we're using function notation. So this f of x is just notation. It's a way to name a function, and it means that it's in terms of x, which means x is the unknown variable. And f of x is the value of the function f at the number x. So it is the value of y when x is equal to x. So just like when we find f of 1, that tells us to plug 1 into the function f. So for example, if they gave us the function 2x minus 5, and they told us to find f of 1, then we would plug 1 into f everywhere we see an x. So 2 times 1 minus 5, and 2 minus 5 is equal to negative 3. So therefore we can say that f of 3 is equal to 1, which means that 1 is the y value when x is equal to 3. Okay, I'm going to kind of let you read this. You can pause it and read it yourself, but it's pretty much just saying that functions are like a machine. So for example, if I had this function, x is the input, so I put a number in for x to get for my input, and then whatever that is equal to for my y, that would be my output. So for a function y equals f of x, the variable x is called the independent variable because it can be assigned to any number from the domain. And y is called the dependent variable because it depends on x. It is dependent on x. Whatever value we plug in for x will change the value that we get for y. And the independent variable is also called the argument of the function. So if you remember in class, I kind of sped through this slide and was like, hey, do you guys remember how to do this? So these are just a couple examples. They give us this function, f of x equal to 2x squared minus 5x. And they want us to evaluate a through h. So the first one is to find f of 2. So we're just going to plug 2 in everywhere we see an x here. So we get 2 times 2 squared minus 5 times 2. And after evaluating that, we get that it's equal to negative 2. So we can also say that the image of 2 is negative 2. So the output is also called the image. Okay. Second one, B. Did they skip that one? F of x plus f of 2. Oh, here it is. Okay. So f of x plus f of 2. So f of x is just the original f of x that they gave us, which is 2x squared minus 5x, plus f of 2, which we just seen was equal to negative 2. So after evaluating that and simplifying, which there really isn't anything to simplify, we're left with that. So this is just about learning how to read the notation and what it's asking us to do. C was 2 times f of x, so now we're just going to multiply the original f of x by 2 and get 4x squared minus 10x. D is f of negative x, so now everywhere we see an x in f of x, we're going to put negative x. So that becomes 2 times negative x squared minus 5 times negative x. Negative x squared is positive x squared, so that becomes 2x squared and then plus 5x because we got two negatives there. Next one, negative f of x just tells us to multiply f of x by -1, which will change the signs of both terms. Okay, I'm going to skip f. You can read it on your own. F of x plus 2 tells us to plug x plus 2 in everywhere we see an x. So that will give us 2 times x plus 2 all squared minus 5 times x plus 2. Of course, we would have to FOIL this to get this, and then distribute that -5. And after simplifying everything, we get this as our answer. H, last one, I believe, is f of x plus h. So now I'm going to plug in x plus h everywhere I see an x into the function f. Of course, I will have to FOIL this, and that will give me x squared plus 2xh plus h squared. Distribute my -5. And then combine like terms to get this as our final answer. Okay. So notice that when we found f of x plus 2, that was not the same as f of x plus f of 2. So this doesn't work. This is not equal to this. These are not equal. You cannot do that. Okay. So now I'm going to talk about how we can use our calculator to find values on a function. So the first example is if we have the function f of x is equal to x squared. And let's say we wanted to find f of 5.678. So of course we could plug this into the function and get 5.678 squared, and that will give us that. But I want to show you how to do this on your calculator. So I have the calculator here. So if I go to y equals and I type in x squared, which it's already in there, and then you can hit, you can hit graph or clear. You can just go back to the regular screen, and then you can go to second calculate and go to value, which is number 1. So I'm just going to hit enter, and then it gives us the graph of that parabola, the x squared, and we can type in a value for x, and what was it, 5.678. So I'm going to type in 5.678 and hit enter. And then it gives me the y value there down at the bottom in blue. So the y value at that x value is 32.239684. And so that is how you can find values in your calculator. So I'm not going to do any more of those examples, and you can play with that in your calculator and compare. Okay, so in general, when a function f is defined by an equation in x and y, we say that the function is given implicitly. But if we can solve the equation for y in terms of x, then we say that the function is given explicitly. So for example of implicit forms, we have these three here, and you can just see that the x and y, they're on the same side of the equation. Y is not by itself. And so this is implicit form. But if we solve those equations for y, then they would be in explicit form. All of these important facts about functions we've kind of already talked about, so you can pause and read this on your own if you'd like. Okay, and so now we're going to talk about finding the difference quotient of a function, and this is the same thing as really finding the slope or average rate of change. Of a function. So remember we had the slope formula to find the slope between 2 points on a line. But if we have a function that's not a line, let's say we had a curve, I'm just going to make this up, and we wanted to find the average rate of change of this function. This isn't a line, so it's not the same thing as slope, but we just want to kind of know the average rate of change. How much is it increasing as x increases or vice versa? So the way we do that is we kind of, if we wanted to know the average rate of change between 2 points on this function, say these 2 points, then we can connect a straight line between them. And then we can find the slope of those 2 points. So let's say this point was x comma f of x. Then the next point could be x plus h, so the difference between x and the next point is just h, and then f of x plus h. So h is just the difference between the first point of x and the second one. Okay, and then we can use these two points to find the slope, or the average rate of change. So y2, we could let be f of x plus h, and then minus f of x. And then our x2 would be x plus h minus x1, which would just be x. So this is where our difference quotient formula comes from, and you're going to see it on the next page. Notice that down here, these x's will cancel, leaving me with just h. And so here is the difference quotient, f of x plus h minus f of x over h. And again, this is the same thing as the average rate of change between 2 points on a function. So for example, I had markings on this, let me erase them. It says find the difference quotient for each function. So the first one is f of x is equal to x squared minus 1. So to find this, we have, here is the difference function formula, difference quotient formula. So the first thing I'm going to do is find f of x plus h, which tells me to plug x plus h everywhere into f. Let me actually use some different colors here. So this is plugging in x plus h into x, into f. So this would become x plus h squared minus 1. That's all of that first part. And then minus f of x. Oops. And f of x is just equal to x squared minus 1. So this becomes minus x squared minus 1. And then that will be all over h. It's because of the formula. So then, of course, we would have to FOIL this, which will give us x squared plus 2xh plus h squared, and then minus 1. And then we distribute this negative here to get negative x squared plus 1. And then we just combine like terms on the top, so the x squareds cancel. The negative 1 and the 1 cancels, and it leaves us with 2xh plus h squared. And then we can see that every term has a factor of h, so they factor out an h out of the top, and then they cancel the common factor of h, and that leaves us with 2x plus h. So that is the difference quotient for that function. Another example, if I had the function f of x is equal to 1 over x, then f of x plus h would be 1 over x plus h, minus f of x would just be subtracting the original function, and then it's all over h. All right, so from here, let me put some parentheses here to see how we get from that step to the next step. And actually, I might do this on a separate slide. So let me add okay, so we are here. This is where we're at, and we want to simplify this. Okay, so when you have multiple fractions in a fraction, you need to multiply the top and the bottom by the least common denominator. Okay, so the least common denominator of the top, by the way, because the top is what has two fractions. So the least common denominator of the numerator, since there's fractions in the numerator, is equal to x times x plus h. Just multiply those two denominators together. So I am going to multiply the top and the bottom by x times x plus h to keep my fraction equal. Okay, so of course on the top this will be a distributive property. When I multiply it by the first fraction, the x plus h's will cancel, leaving me with just x times 1. And then when I multiply it by the second fraction up there, the x's will cancel, leaving me with negative 1 times x plus h. And then on the bottom we'll have x times h times x plus h. So on the top, we'll distribute that, give us x minus h. And I'm just going to leave the bottom as this product real quick for right now. Now the x's will cancel on the top, and that will leave me with, let me put some equal signs here, sorry, negative h over x times h times x plus h. And so these h's will cancel, leaving me with negative 1 on top times x plus h. And then I can't do anything else from there. So this would be the final answer. And that's what they got right here as well. Okay, and we'd be done. Okay, I'm not going to do this example, I think. Maybe I'll just go over it real quick, because this one has a square root. So our original function is 2 times square root of x. So for the first part, we get 2 times x plus h, or 2 times the square root of x plus h. And then f of x is 2 times the square root of x. And then from here, what they're going to do is multiply the top and the bottom by the conjugate so that they can try and cancel out some of those square roots. So this is the conjugate of the numerator. So usually if you ever need to try and simplify square roots, you can multiply the top and the bottom by the conjugate of the expression with the square root. So they're just changing the sign in the middle. And so the top there will become a FOIL. And so you'll have to do the 2 square root of x plus h times 2 square root of x plus h. And that will give us, use a different color here. That will give us 4 times x plus h, if you FOIL that out. And then when we multiply the negative 2 times the square root of x times itself, that will give us 4 times x. And then of course on the bottom we just have all of that multiplied by h. Some stuff will cancel on the top there. 4x minus 4x will cancel. And then we can cancel the h's. So this will be our final answer. Okay, so now we're going to be talking about how to find the domain of a function defined by an equation. So sometimes they'll give us an equation and they'll just want us to figure out the domain of that function. So when we do that, when we're asked to find the domain of f is the largest set of real numbers for which the value of f of x is a real number, or when it's defined. Okay, so whenever we are given a function and asked to find the domain, we need to think about the restrictions on the function. And you'll see what I mean by that. Okay, so first example wants us to find the domain of f of x is equal to x squared plus 1. Well, if you look at this function and you think about the restrictions, there is none. I can plug any number in I want to for x. I'll get an output. There's nothing that's going to create an undefined value in this function. Doesn't matter. I can plug 0, I can plug negative numbers, everything. So the domain here is the set of all real numbers. An interval notation to represent all real numbers is from negative infinity to infinity, parentheses. Okay, next one is g of x is equal to x divided by x squared minus 25. So if we look at this and think about the restrictions, we cannot divide by 0. So anytime you have a fraction that has an unknown variable in the denominator, you need to make sure you're excluding any values that makes the denominator equal to 0. So therefore, we can set x squared minus 25 equal to 0 and solve for x. And this will factor to x plus 5 times x minus 5 equals 0. So x cannot be negative 5 or 5. So therefore, the domain is the set of all x such that x cannot equal negative 5 and x cannot equal positive 5. It can equal any other number. Okay, and then the next example is the function h of t is equal to the square root of 5 minus 5t. So if you think about the restriction on this function, we have a square root, and we cannot take the square root of a negative number. And therefore, this expression, 5 minus 5t underneath the square root, has to be greater than or equal to 0. Has to be, or it'll be undefined. I can't take the square root of a negative. So I need to take the entirety of the expression under the square root and set it greater than or equal to 0 and solve for t to figure out what my domain will be. So they subtract 5 and then divide by negative 5. And when they divide by negative 5 here, it's going to flip my sign. So therefore my domain is all values of t that's less than or equal to 1. And interval notation, that would be starting at negative infinity and going to 1 with a bracket since we're including 1. So that is our domain. Okay, so for this one, you're going to have 2 restrictions. Can't divide by 0. And can't take the square root of a negative number. I don't know what's going on. So I need to count for both of those. I need 2x plus 6 to be greater than or equal to 0. And I need x minus 2 to not equal 0. So therefore, I get that x cannot equal 2, and x cannot equal, or x has to be greater than or equal to negative 3. So on a number line, we have negative 3 and we have 2. So this is saying that x has to be greater than or equal to negative 3. But then we have to leave an open circle at 2 because it can't equal 2, but it can equal everything else. So this can be written in set notation as x, the set of all x such that x is greater than or equal to negative 3, comma, and x cannot equal 2. In interval notation, this would start at negative 3 and go to 2 with a parentheses, and then I would have to unite the second interval, which starts at 2 with a parentheses and goes off to infinity. Okay, you can pause and read this on your own. It's pretty much saying everything I've said about the restrictions. And when we do find those values of x that are not in the domain, we just say that f is not defined at x, or f of x does not exist. Okay, so let's see this in an application problem. This says express the volume of a cube as a function of its side length and find the domain. So the formula for the volume of a cube is the length of its side cubed. So, of course, we don't want the length of this side to be negative, because length can't be negative, and we don't want it to be 0, or we wouldn't have a cube. So for this one, you're kind of just thinking about the application. Length can't be negative. Can't be negative or 0 when we're talking about the volume of the cube. So therefore, s, the variable, which is the length of the side, has to be greater than 0. So that would be the domain of this application. Okay, and the last part of this section is so long, that's why I did this video. After looking, it's like 55 slides. So there was a lot here, so I just wanted to make this video. But the last thing we're going to do is kind of just talk about the algebra of functions and how to add them, subtract them, multiply, and divide them. So the first one is the sum of two functions, so we can write that as f plus g of x. This is the same thing as f of x plus g of x. And it just tells us to add these two functions together. And then subtracting f minus g of x is the same thing as f of x minus g of x. So in these, we're talking about if they give us two functions. F of x is equal to something and g of x is equal to a function. So we're just adding them or subtracting them here. Multiplying them, the notation is written like this, f dot g of x, and that's how we read these, by the way. F plus g of x and f minus g of x, f times g of x, and then f divided by g of x. Will be written like this, and this is the same thing as f of x divided by g of x. So let's look at an example. So they give us these two functions. F of x is 2 over x plus 3, and g of x is, let me use a different color, x divided by x minus 4. So they're going to ask us to find all of these, f plus g, f minus g, f times g, and f divided by g. So the first one, f plus g is the same thing as f of x plus g of x, so I'm just going to be adding f of x plus g of x. And if I wanted to combine this into one single fraction, then I could get a common denominator by multiplying the left fraction, top and the bottom, by x minus 4, and then multiplying the right function by x plus 3. So I can get a common denominator. So that's what they're doing here. They get 2 times x minus 4 on top, and then x plus 3 times x minus 4 on the bottom of that one, and then x plus 3 times x, and x plus 3 times x minus 4 on that one. Now we have a common denominator, so we can add the two numerators together to get 2x minus 8 plus x squared plus 3x after distributing. And then combining like terms, we're left with this. Okay, so this would be the simplest form. You always want to make sure you can factor, or see if you can factor the top or the bottom and simplify, but this can't be factored. So now what if they ask us about the domain? Well, the domain of this function has to exclude -3 and 4, since that makes the denominator equal to 0. So therefore, the domain of f plus g is the set of all numbers x except for -3 and 4 because of that denominator. Okay, f minus g I'm not going to do. You get the same thing for the domain. F times g, you're just multiplying the two functions together. And the domain of that would, again, still be the same. Can't equal -3 or 4. The last one is dividing the two functions. So we see f of x divided by g of x. Now remember here, when you divide two fractions, you keep, change, flip. So you can keep the first one, change division to multiplication, and then flip the bottom one. Take the reciprocal, and now we can just multiply to get this. So now our domain, x cannot equal 0, and x cannot equal -3. But also, we have to take into account the domain of g of x here. Because originally we're plugging in g of x into the function, but the original g of x had a denominator of x minus 4. So that also can't be undefined. I can't plug in 4 there. So here, x cannot equal -4. So the domain of these functions, like when you do these algebra functions, it's always going to be the intersection of the domain of the original functions and then whatever else needs to be added for the final function. So because the original function here of g of x has a domain of x can't equal -4, that will always be included in our domains for our final answer. And you see that with the other ones. 4 is included there, 4 is included here, 4 is included there. So it's not as obvious on this last example with the final answer, but we have to include it because it was in the domain of the original g of x. So that would be our complete domain. Okay, now this is all of 3.1, so I will go ahead and post this video and try to get 3.2 and 3.3 done by today. Thank you for being patient. I've had a lot of technical difficulties while I was in Georgia and was unable to even create videos. It wasn't letting me create them. It wasn't letting me upload anything. So I'm really sorry. I'm trying to get this done today. Thank you for your patience.